Hello everyone. In this demo, I present ML Quadrat++, a model-driven framework for building IoT application with integrated time series forecasting. I will show two editors, a quick start textual editor and a graphical editor based on Serious Web. The main objective is end-to-end automation, modeling, code generation, executions, and visualization. The example is a time series forecasting workflow integrated into an IoT-style component architecture. First, I start with the quick start editor and define the system in ML Quadrat Plus with SingML syntax. Then I generate and run code directly, and I inspect logs and plots produced by the pipeline. Finally, I switch to the graphical environment and show the equivalent concept using forms and diagrams. On the screen, the left panel is the textual models and the right side provide output views. The bottom's action includes save, generate code, run code, and plot options for preprocessing and forecasting. I begin by describing the IoT architectures in a river flow forecasting example with three key components: sensor client, flow server, and flow analytics. The sensor client is responsible for sending sensor message containing future value. The flow servers act as a mediator forwarding message and coordinating requests. The flow analytics components embeds the ML pipeline and produce forecasts used by runtime logic. This is important. ML Quadrat++ link analytics executions directly to components behavior. Next, I define the data analytics um, specification include data preprocessing, time series forecastings, evaluations, and model setting. Um, In the model block, I define the time series models. In this demo, I selected an MLP models. I specified key hypermeters, layers, neurons, activations, functions, optimizer, and number of epoch. I also defined training settings such as batch size and regularizations where applicable. Next, I define evaluation metrics such as MSC and RMSC to quantify forecasting error. Now I run the pipelines from the interface. The tool generates scripts for preprocessing, training, and predictions, and executes them. The console output display training progress, including epoch level loss. This confirms that the code generations and executions are working end to end. After executions, the system produce artifacts such as logs, plots, and predictions file. I now inspect the result and related them back to the model configurations. This closes the loop between modeling choices and empirical outcomes. And now you can see all of forecasting plots here. Now I will switch to the README to show how to run Serious Web. I move to project setup instructions. I'm on the README getting started sections. This part explains the project structures and how to services are organized. I highlight the Docker Compose commands, build, then up. Here are two important URLs shown in the README, and this URL are for orchestrator, and serious web. Um, I explained that we use serious web as the graphical editor for ML quadrat plus plus models. You Now I open Serious Web to start modeling visually. You can see Explorer on the left, central canvas, and a detail panel on the right. Um, I briefly describe what each panel is used for while the page finish loading. Next, I create a new model in the Explorer. I create a new model and name it River Flow. Um, the model will contain our type, message, sync port, and data analytic configurations. I type the name, confirm the model type, and click create. Once create, I will open the representations to draw the architecture. Now I create a new representation starting with things and connections. Next, we will use the canvas toolbar and add elements. At the bottom, you can see message box like um, sensor data, add query, alert, and save. I point to the top toolbars for zoom selections and layout tools. Now I start adding the main components of systems. I begin adding the core things that forms the IoT architecture. In this example, we use a sensor client, a flow server, and a flow analytic components. I place the blocks on the canvas so the structure is clear and readable. Next, I add the ports to define communications. Ports define provided and required interface, and they control which message can flow. Next, I assign message fragment to the port. I open the context menu for selected element. I confirm the port so models knows which message are allowed on that interface. Now I continue wiring connections between things. The goal is to connect sensor client to flow server and flow analytics using message such as sensor data, query, ACK, alert. I adjust positions and lines so the diagrams remain clean. And next, I focus on the flow analytics service interface. I added the connect the file service port, which is entry point for analytic request and result. I ensure the connections lines match the intended directions of communications. Next, I select the data analytic element to configure the pipeline. With data analytics selected, the details panel show configurations field. This field include dataset label, timestamp, threshold, preprocessing switch. I explained that the configurations drives the generated Python script. Next, I open the dedicated forms view for easier editing. I open the form view for the data analytic configurations. This form is organized in two tabs: data preprocessing, time series, model evaluations, and visualizations. I navigate to the preprocessing tab to set transformations. Now I select concrete preprocessing options. So in preprocessing, I choose how raw data will be prepared. This include future scaling, sample normalizations, missing value handling, and so on. Uh, After completing configurations and modeling, we move to executions in Orchestrator. We will download the rivalpro.xml. Then we upload the XML files in the Orchestrator. And also we upload the dataset. Now
You will see the project generation and executions outputs. I point to the dataset upload area that lets you attach the input. Next, I show what appear after executions. Download report. Now I show the generate console output. Finally, I open the image report. At the end, we can download and inspect the produce artifact.